Okay, so what we're looking at right now is linear regression output. So what we have is we have a scatter plot, and we have a residual plot, and we have the regression output itself. So what I want to do is go over some key pieces of this. The first thing is on top, it tells you what the dependent variable is. It's fair, okay? So that is going to be our response variable, okay? So if we look at this, then the explanatory variable is distance. So that's explanatory, and that's response. Okay? The second thing I want you to look at is r squared. So r squared is right here. Now there's one right next to it called r squared adjusted, and we're not going to use that. We're just going to use r squared. So right here we know what r squared is. Okay? The next one down, when you see this 18 minus 2 here, that means that this 18 right here, that's n. So there are 18 points on that line. So if you counted the line, the points on the line, you would see that there's 18 of them. Okay, so there's n. Okay. And then what I want to do is, we're not going to deal with this stuff right now, but what we are going to do is we're going to skip down. This number next to constant, this number right here, that's b sub 0. And this number next to distance, okay, since distance is our response variable, this point's 0.78619, that's b sub 1. Okay. So the first question says, is the linear model appropriate? Explain. Well, what tells us if a linear model is appropriate? The scatter plot, is it straight enough? So we look at the scatter plot. So the scatter plot is straight enough, and the second thing we look at is the residual plot shows no pattern. So in this case, yes, because the scatter plot is straight enough, and residual plot shows no pattern. Okay? So then the second question is, how strong is the model? Well, we use two things to explain strength. Okay, we're going to talk about R, and we're going to talk about r squared. Well, we already know what r squared is. It's 48.2%. That's right up here. Okay, and that's going to talk about variation. So how do we get r? Well, we take the square root of r squared. Okay, so what we're going to do is, we're going to go to our calculator, and we're going to take the square root of 0.482. And it's 0.694. So here, r equals 0.694. So what does that tell us? Strength direction of a linear relationship. So we have a moderately strong, positive, linear relationship between distance and fair price. Okay? So that's what r tells us. Now we're going to talk about r squared. R squared is 48.2%. So 48.2% of the variation in our response variable in fair is explained by the linear relationship with distance. Of course, the phone would ring now, right? Okay, so are there any outliers? So I look at the scatter plot, and I do not see any outliers. Okay, so I look there. You might argue this one right here, but it's really not outside of the trend, so I'm going to say no. There don't appear to be any. Okay. And then what I'm going to do, we got to write the least squares regression line equation. So we need b sub 0 and b sub 1. So we're predicting fair here equals b sub 0, 177.215, plus 0.078619, which I got from right there, times distance. Okay. And then it says interpret b sub 0 and b sub 1 in context. Okay. So let's do b sub 0 first. Okay. When distance equals 0, fare is about $177.22, which is ridiculous because no one would pay $177.22 to fly nowhere. So this is an extrapolation, and is probably not reliable. It's meaningless in this problem. Nobody's going to pay $177 to hop on a plane and sit there and go nowhere, so it really has no meaning in this problem. But the slope, 0.078, so I want to say 0.079. So it's basically that fare increases about 8 cents per mile. So for each mile that you fly, it costs you about 8 cents more. Okay. And then let's talk about a 1,000-mile trip. So we're going to do predicted fare equals 177.215 plus 0.078619 times 1,000. So let's just put that in the old calculator. So we got 177.215 plus 0.078619 times 1,000. So it's 255.83. So we would say that for a 1,000-mile trip, it will cost approximately $255.83 according to the model. So that means what? It may not cost that, but that's what we're predicting it's going to cost. Okay?